We'll leap straight in. So this is the guidance, and as Paul said, free to download from the Sustrain website. So if you haven't done so, please do so as soon as you get home. And really just to talk, I should just say, the guidance was written in collaboration between myself and Steve Wilson from EPG. Steve is a hydrological and geotechnical engineer, so he primarily worked on all of the nitty-gritty technical stuff, but it was very much a very strong collaboration between the two of us to produce this guidance, along with a wide range of people across the industry, both contractors, manufacturers and designers, sharing their knowledge about the issues surrounding SuDS construction. So, why we did it? Well, I think there has been guidance. There was old guidance produced by SuDS, but it really was quite out of date insofar as things have moved on massively from when that was first produced. We felt it needed to be much more appropriate to the audience, that is, the people actually building SuDS on site, and we wanted it very much to be a companion document, or SuDS did in particular, to the SuDS manual that had been published the year before. And we also now understood that there were plenty of inadequacies arriving during the SuDS construction process. So, the first thing we did was undertake an industry-wide questionnaire on the challenges that people had encountered in constructing SuDS, and the messages came back absolutely loud and clear. The three things that people highlighted primarily were level changes happening on site, things being changed on site that had not been anticipated. The fact that cut and fill really, in the main, was not particularly dealt with properly in advance, and that had serious implications for the construction of SuDS when people actually got on site. And then inevitably, conflicts with services, not only on retrofitting where it's almost guaranteed to happen, but also on new build sites where services have not been properly coordinated, may have been installed early, and then having conflicts with what you're trying to do with the SuDS later on. And then there was a whole series of other problems, particularly things where people involved in the concepts not maybe taken through to the detail, so inadequacies in the design drawings occurring, recording of site information not being particularly accurate, and then things changing throughout the construction process where additional hard surfaces are required but the drainage is not addressed, changes of materials that may not have the same properties, and then changes just happening on site because they do, and or poor construction. And frequently the fact that many contractors are only building SuDS for the first time or the first couple of times, or particular components for the first time. And some of those mistakes are really just absolute lack of knowledge and no intention there whatsoever. Other things that cause problems, interestingly, issues of areas of ecological importance or tree root protection zones really didn't cause problems at all during SuDS construction in the main. And I think that's probably because contractors understand that they need to be careful in working around these things anyway. But generally, problems of visual quality, physical structure and functionality really just were spoken of all the time. But actually, issues about difficult sites, or sites that are considered difficult in SuDS terms, actually most people hadn't come across them and they didn't seem to be particularly problematic. I think the fact that there were known difficulties on particular sites, if you're, say, dealing with contamination, that people have really addressed those issues in the design process anyway. So that's what it looks like, that's the contents of it, and what I'm going to do is just whiz through the whole document quite quickly to give you a flavour of what's there, and hopefully then you'll go and look at the things that you need to. The whole point about this is because it is absolutely geared around the people working on site, we're not talking about design, we are purely talking about construction. The idea is that it's written in very simple English, as few words as we could make it, perhaps not quite as few as we'd hoped for, lots and lots of images to explain what we're talking about, very few words, using symbols, and the fact that it's about sharing knowledge and little jargon. So those were the things that the tasks we set ourselves to do. And typical of that is we've got things like jargon busters. So you can read any chapter in this document and any word that we thought might be jargon. And the one that came up most was the word component, which is probably in almost every single chapter, is highlighted at the end of the chapter. So if you pick it up and open it, you can understand that chapter as a standalone thing without having to know anything else about it. And also the fact that we had the steering group and people were very generous in sharing the issues that they'd had to address on site and sharing images of the problems that had occurred. So we've got this sort of traffic light system, handy hints. So that's information that we have all gleaned about SuDS construction that might be helpful to you in what you're doing. A watch point where there's a situation that might arise that you need to watch out for because that could cause problems, or things we identify as a hold point where, really you do need to stop, think about, check, and make sure that it's right before you move on to the next stage. And this learning from others' experiences, we have a lot of case studies in there. In most of the chapters, we have what we call mini case studies, and this is an example of a mini case study, and then 5 major case studies at the end. And I love this case study, and I'm looking at the person who gave it to me, where a contractor had completely inadvertently utterly misunderstood the drawings, and these granite sets are actually an outfall. So I'm presuming it specified granite sets, but not that they went right over the end of the pipe. So as you can imagine, that all had to be dismantled and actually rebuilt properly. But you will be surprised what can happen on site. And of course, the point of all of this is, and I'm saying about working with the 4 pillars of SuDS, because actually if we want to deliver all of these things, then actually the biggest issue that we have on site is all about soils and silt and managing sediments because of the problems that we have in trying to reinstate damaged soils and the need to maintain what we've got there. And most of the issues really do orientate around that problem. So, this is what's different about building SuDS. Well, these are the 4 issues really that we're talking about in how to get it right. So being properly prepared, planning the works, planning to avoid potential site problems, managing those works on site, and then looking at the typical challenges specific to the SuDS components. And these are the key chapters in the guidance. So really, the first chapter is really just explaining the background of it, hard and soft, multiple benefits and the need for care in construction, and why SuDS can affect construction planning. Then the second chapter is about the pre-construction side of things. And really, that's about being properly prepared, the baseline information, making sure you understand everything about the site and the scheme and the off-site issues that might affect, on-site and off-site issues that might affect construction, checking how the design works and making sure that you understand how it works from where the rain falls to the outlets and everything that connects it in between, and those on and off-site considerations. And every chapter's got a checklist associated with it, just as a reminder, giving you the idea of things that you might need to check. It's not necessarily comprehensive, but it's there to just, give you a baseline to work from. And then talking about the team and who are going to be delivering this, the construction planning and programming that they need to do. So that's looking at the site team itself, understanding the phasing requirements of the site, making sure you get the right materials for the job, and then, again, as I say, checklists. So there's quite an interesting analysis in there, which, you may be interested to read, actually looking at, it's the same people that deliver any construction contract who are going to be working on constructing SuDS, because clearly in the main they're going to be building something else. The point is that when it comes to SuDS, they need to have a slightly different role in their consideration of how they're actually going to build those features. And it is an interestingly different approach that you need to take, and I find that actually running not quite toolbox talks, but being involved in that process is really important in communicating those issues to the site management team, down to the guys on the tools when you want to actually build some SuDS. Phasing is a particularly thorny issue, and this is an example that we give of a real-life site, and we particularly wanted to choose a housing site because it has really quite interesting issues about the phasing, and this is a site that Steve Wilson was actually working on. and he sat down and went through with the contractor the issues that had influenced how they had developed it. So as you can imagine, as it's a housing site, the first thing that they want to do is build the show homes right at the entrance at number one, at which point it's pretty much impossible to connect the SuDS into the outfall where it needs to be in the long term. So the need for temporary connections. The fact that they need to actually have the main road into the site constructed, and the fact that if you want it to be permeable paving, then clearly you can't put those finishes down until the very last process because of the amount of silts and sediments that are going to get into that construction. So how you think about that construction, how you manage that process. Because as you can see, that actually when you get to the final scheme, the SuDS components are right in the middle, which for most of the contract are going to be used for the materials compound and the car park. So the need to understand how you can really plan each of those phases, that they can be connected into a system that isn't going to be damaged by subsequent works, how you're going to access those sites and how you're going to deliver that. And this goes through in some detail, that process and how that was managed on the site, really just to show some of the issues that need consideration. So managing the site. These are really the problems that are arising as a consequence of the process. And as I said before, much of this is about soils, the site access, and then the erosions and silt problems. And this is just a page showing you what it looks like in the main guidance. As you can see, image rich. And what we've used is this thing of saying, getting it right, thumbs up. What can go wrong if you don't? Very much a thumbs down. And as many pictures as we can of the things that go wrong. And if we couldn't get pictures of things that have gone wrong, actually, we'd just quite like to show you some nice examples of where people have got it right. But I think this shows you quite clearly the sort of detail and the amount of information we're trying to get into, and making this, talking very strongly, particularly about the need to manage these soils properly. Site access, I think, always deserves special mention. And this is the technique that you can use. There's several we talk about how you can maintain site access where you want to put down permeable paving. So the technique is to put down your permeable subbase and then protect it one way or another, in this instance by putting down an asphalt base course. Then once you've finished your construction and you don't have any more machinery or mud coming onto the site, then you can clean that off, core out the asphalt to a particular size hole at a particular density and configuration as they're doing there, fill those holes with grit, and then lay your permeable paving on top. That will function absolutely perfectly as it would as if you just put it on a straight sub-base. But really important to know that, to know how to manage those sorts of things. And as I say, there's several options demonstrated as to how that can be done. And then, really these problems of, this is often about timing. When you bring things into use on site, knowing that you can protect them in an adequate way. Clearly there can be problems over timing with things like swales, where actually can you get the grass to grow at that time of year? So again, tips probably about swales. If you need to bring them into action quickly, that you might think about turfing the base of your swale. And even if you want wildflower grasses on the sides, actually those will seed in and develop over time anyway. And then establishing planting, and really just talking about why you should plant early, because if you want to get these water quality improvements and you want to and have that early, and you want to get these things established well before you put the water down them, because of your problems of actually generating erosion yourself if you're not actually ready for those plants to go in there. So they are a very important part of the scheme, and so getting them right is important. So why plants die? Well, that's possibly more of a specification issue. You can't mess about with the plants that have been specified because they need the properties that they've got. And a common mistake is thinking that you need wetland plants in all SuDS. You don't. If you're using bioretention features, you want plants tolerant of a wide range of conditions. If anything, drought-tolerant plants and plants of a wide range of conditions, not wetland plants. So understanding those plants and making sure you're working with the specification and not taking last-minute substitutions that are inappropriate is one big feature there. Okay, so this is just generally looking at the issues around construction rather than the components. So various section there, just really the warnings about variations and considering their potential impact on SuDS, particularly increases in hard surfaces, changes in levels, and changes of materials that may not have the same properties. Even things down to the difference of just changing the diameter of an outlet, what an implication that can have on the discharge rates. So, very important to stick with what's been specified. Tolerances, we're only really dealing with tolerances related to SuDS features, not tolerances generally. And in the main, this just directs you to the industry standards. And particularly making sure the other things about materials and aggregates, geomembranes, knowing why these things are specified and making sure you don't make changes inadvertently. Looking at the difficult sites, again, this isn't a massive problem, I think we found, because you have to have addressed these issues in the main during your specification, but particularly with high groundwater to actually manage the water flows into the excavations. Otherwise, you'll see your tanks floating out the grounds if that's what you're using. Contaminated land, again, because you've got an appropriate scheme, or you should have, this is much more about managing that contamination and documenting it, and that would all be, with contractors who are actually approved and regulated to do that. So again, seems to be less of a problem. And then the soils, understanding the different types of soils and making sure you use them in the right place, that you don't mix them up, that people understand that they have different properties and that they have a very specific use in the scheme. So natural and specialist soils are just ordinary soils, specialists being ones with either high or low pHs. Manufactured soils are ones that are created. In the main, we would say use them in your landscape scheme adjacent. They're not going to be quite so good if you're wanting to mix the soil as part of a bioretention planter mix. Then filter media, so that's something where you're looking to actually really get strong drainage or to impart an attenuation feature. Structural soils, where you're going to want to be able to compact those soils to enable paving over the top. And then engineered soils, which are the ones that you're going to use in something like a bioretention feature as the main soil, where you are also going to want plants to grow. So really important that if you're bringing them into site or storing them there, that they're clearly identified. People know the differences, know where to use them, don't mix them up. Otherwise, you could have a little bit of a disaster there. Okay, inlets and outlets, well, this is all about pipe sizes, head walls, flow controls, making sure that the discharge rates are right and that you stick with the specification and that you've got the right capacity in the system for what you need. And then, of course, the visual and management issues. It's got to be maintainable, so that's much more about sticking with the gradients that you should have. But I have to say, outlets are absolutely my bête noire, and getting good ones that don't look absolutely atrocious, and we have an absolute catalogue of atrocious examples. So there are good products coming on the market now, but they really need also care and construction. But some of them are just downright ugly. That's a different issue. 2 minutes. Okay, we're romping away, Paul. Don't worry. So materials here. This is just about the right one in the right place. Understand it and not changing them, as I've said before, and particularly understanding with geosynthetics the difference between geomembranes, geotextiles, geocellular confinement. They've all got different properties. Right thing, right place. So this is the SuDS components. Just going to show you, I think I've only got this one, I can't remember, bioretention systems. This is typical of how a chapter, so every SuDS component has its own little chapter. So we'll talk to you about what they are in general, how they work, show you how they can be different in different circumstances as an isolated thing on its own, as a planter, where it might be in a street situation or just actually within a scheme. So the different sorts of things, and then looking at the challenges related to all of those things. And so there we've got a very typical example, that first one. That should be a bioretention planter which is free draining. The contractor looked at that bioretention filter medium, thought it looked a bit awful for plants, I think, and very kindly put some nice healthy clay soil over the top, which stopped it draining. Very easy, just a mistake to make. And so again, as I say, lots of examples of getting it right and things going wrong there. And a case study, again, talking about, again, lack of understanding with the contractor, fire retention planter. Normally the soil is set down, but we've ended up, because in normal landscape schemes, the soil comes up higher. So didn't work. So they had to take the plants out and they had to lower the soils. So I've got there. So really just to say, I personally have found that, in writing this guidance, it's taught me so much about how to design. Understanding how to construct things really does focus your mind on the way that you design them. So I would commend it to you on that basis anyway. But putting suds on the ground is all about teamwork, and this, I think, helps generate a dialogue with the guys on site about what they're doing, how they do it, and that way we can prevent the problems arising, because they'll understand what you're talking about. Because at the end of the day, we need to deliver good water management and reduce